And after this one, I think we'll be set. The one thing I didn't do is I didn't do one where you had to do long division first. Or maybe we do have to do long division on this, you guys tell me. But if you have to do long division first, do it, and then do partial fractions afterwards. It's very possible. I'm sure it's on your problems. Okay, so, do I need to do long division? No.
When the bottom is bigger.
And the bottom is how much? Degree
4.
Degree 4. Top is degree 3, so we should be good. Is the bottom factored as far as it can go? Yeah, that's an irreducible quadratic factor that's also repeated. So what are we going to have to do to set this up? Okay, Austin says ax plus b over x squared plus 2. Okay, and then why am I doing b again? Cx plus d over x squared plus 2 squared, since it was repeated. There we go. So that's what we've got to do. We've got 4 unknowns to solve. I'll just get rid of the integral for now so we can think about it like that, right? So the common denominator is right here, so think about multiplying that through both sides. Should I just do it this time? I'll do it. I haven't been doing it because I don't like making my work messy, and I'd probably advise you guys to try to do it in your head. It gets really messy otherwise. Right, that's really what's happening. So it totally cancels out here. So what's left is cx plus d. Oh, and I need to do it to both sides of the equation. Don't want to disobey the Old Testament rule and have God out for my life or something. This guy cancels once. I'm gonna put it over here. And this cancels both. So there we go. That's what we've been doing, yes? Instead of plugging in convenient values, we're gonna have to do something else in this. Why? There are no convenient values that'll make parts go away this time. So you've got to use matrices, which we can do one tomorrow. If you guys want to see one, we'll do one maybe next week if you guys don't want to see one yet. Let's do what we did last time and equate coefficients. This one should come out a little cleaner, I think. So this side's expanded. This side I get what? An ax cubed and a 2ax and a b times 2 and a bx squared. This part's done. So collect your like terms. So we just got one cubed thing. That's nice. That ought to give us something. X squared terms. Do we just have one? I don't think I made a mistake. So just bx squared. That's nice. This is a really nice technique a lot of the time. It makes it easy. X terms. We've got the ax, 2ax, and cx, right? So I'm going to factor out the x. And I've got 2 a's and a c. Does that make sense? And you might cross these off as you go so you don't, especially on that other one, because it was like, you know, so crazy, so many terms. But I think good constants. We've got 2b and d. Okay, so now we're going to actually equate them to figure out some of those unknowns. So a is what? 8. Done. See how nice that is? B, do we just know it? 0. How'd you guys know? Because there is no x squared here. So just like in long division or something, you might want to put your zeros in if you know that, though. You know that. So put a 0x squared and a 0 in if you like. Up to you. Then for x, we know that, what, 2a plus c is equal to 13. And oh yeah, a was 8. So that's 16 plus c equals 13. So c is -3. And then what, 2b plus d is 0. So 2b plus d equals 0, and b was 0. So that says d is 0. So now we're done and we can integrate. So keep track of your constants. You might want to do it off to the side. I don't know. D is 0, b was 0, a was 8. Put our integral back in. So we know the integral is equal to, what, 8x, there's no b, plus, oh no, minus 3. I can just pull that minus 3 out in front, right? And that's an x, there's no d.
Can you do that the same with the 8?
Yes, I can. And I should have. And then I hope you guys can do those integrals. This is a u sub, isn't it? Make u the bottom, du sitting on top. You know, like to divide by something. And this one, if you make u the inside, well, let's just do it. So I think that this one is going to be 8 over 2 times the integral of 1 over u du. This one would be like minus 3 integral over 2 1 over u squared du. There we go. So this would be 4 natural log of x squared plus 2 minus 3 halves. And how's that one go?
It would be plus 3 halves.
Positive
Times 1 over.
denominator. Like that. Yes? Good? Questions? Blessing? So that actually wasn't that hard of a problem. Not too bad. All right.